Welcome to Sundar's lecture. This is lecture number 28, and in this lecture we are going to see excitation table for different flip-flops, as well as we are going to see what is raise around condition in JK flip-flop and how we can avoid raise around conditions in the JK flip-flops, right? So what are all the topics we have seen in the previous class? See, we have started with the different types of flip-flops. In the first class we have seen SR flip-flop in deep, and then we have seen what is D flip-flop and the truth table of the D flip-flop, JK flip-flop, and then we have seen T flip-flop, and we have gone to characteristics equation. And I have told you, while analyzing the synchronous sequential circuits, these characteristic equations will be very useful, and it will play a major role in analyzing the sequential logic circuits, right? So we have seen characteristic equation for all the flip-flops, right? And this excitation table, this will also help in designing the counters, synchronous counters. We are going to design the synchronous counters, and while designing the counters as well as while converting one flip-flop to another flip-flop, this excitation table is a very important content, so that you can easily understand the conversion of flip-flop as well as the um, designing the counters, right? So right, this is the excitation table now. So this one we know, right? This is the truth table. This is actually truth table, right? So this is a truth table. So we have seen this one many a times. See this one 0 0. If present state is 0, if you give S is equal to 0, R is equal to 0, then next state will be also 0. And we know this one, right? Everything we know. And what is this one now? This is a state diagram. This diagram will explain you what a SR flip-flop will do. This is a state diagram. We generally call it as a state diagram. This is state diagram or state representation. We generally call it as state representation. What is state now? And we know if it is a present state, then if input changes, then next state will come. That is the idea, right? So this one, both of this one, as well as this one, it is a state now. It is a state, right? For example, if the present state is 0, if I give S is equal to 0, R is equal to 0, then what happens? If the present state is 0, maybe I will take a different color. If present state is 0, if I give S is equal to 0, R is equal to 0, it will retain in the same state. The next state will be also 0. So that is why this 0 will be again stable in 0 if I give S is equal to 0, R is equal to 0. Right? Try to understand. And what is this one now? If the present state is 1, if that means here, we are here now, if S is equal to 0, R is equal to 0, then what happens? The present state will be retained again. This 1 will be retained again. See here, if this is 1, this is S, this is R. This is S, this is R. As well as this is S, this is R. Right? So if this is 1, if I am giving S is equal to 0, R is equal to 0, again it will retain in the 1. That is the idea. Right? What is the next one? If the present state is 0, if I give 0 and then 1, S is equal to 0, R is equal to 1, then what happens? The present state is 0 and the next state will be also 0. Why? Because this is a reset condition. This is a reset condition. See here, if the present state is 0, if I give S is equal to 0, R is equal to 1, then again the state will be retained. As well as you come to the next one now, if the present state is 0, sorry, if the S is, if the present state is 1, if the present state is 1, if I am giving S is equal to 0, R is equal to 1, what happens? This 1 will be converted into 0. Why? Because this is a reset condition. So what happens here? This 1 will go to 0 here. See here, this 1 will go to 0 if S is equal to 0, R is equal to 1. If S is equal to 0, R is equal to 1, this 1 will goes to 0. That is this state. This one I have explained here, right? The next one, if the present state is 0, if I am giving S is equal to 1, R is equal to 0, then what is that? It is a set condition, right? So even if the present state is 0, it will go to the next state will be 1. So here present state is 0. If I am giving S is equal to 0, R is equal to 1, then this will goes to the present state will goes to 1. Next state will be 1. Right? That is what here we have written. And you see this one now. If the present state is 1, if I am giving S is equal to 1, R is equal to 0, it is a set condition. Already it is a present state is 1. The next state will be also 1. See here, 1, 0. And you cannot give these two states. In SR flip-flop, you cannot give S is equal to 1, R is equal to 1. Not possible, right? So that is what we have written here. Very simply, we have drawn a diagram, pictorial representation, state diagram to understand the working of a SR flip-flop. And from this state diagram, we have derived this one now. For example, if this is a present state, Q n plus 1 is the next state, right? So if present state is 0 and next state is 0 now, if present state is also 0, the next state is also 0, then what should be the value of S and then R? That is the idea. See here, S must be 0, right? Am I right or wrong? If present state is 0, next state is also 0, S must be 0, S must be 0, but R can be 0 or 1. It is 0 or it may be 1. So what I can do now, I can put X. It can be anything. It can be anything. If S is 0, then if R is 0 or 1, the next state will be retained as 0. That is what we have written here. That is what we have written here simply, right? And you see here now, if the present state is 0 and next state should go to 1. If the present state is 0, the next state should go to 1. When it will happen? When S is equal to 1, R is equal to 0. Only one condition. So this is what I have written here. S is equal to 1, R is equal to 0. If I do so, then if my present state is 0, then it should go to the 1 in the next state. That is the idea. And what is the next case? If the present state is 1 and the next state should go to 0, then it will happen. The next, if present state is 1, if the next state has to go to 0, then it will happen when S is equal to 0 and R is equal to 1. That is what we have written here. Right? Yes or no? And you come to the next one now. If present state is 1, the next state should retain in 1. And what should be the value of S and R? Present state is 1 and next state should be retained as 1. And what is the condition for S and R? See here, R should be 0. R should be 0, right? R should be 0. But what is S here? It may be 0 or 1. If R is 0, and if S can be 0 or 1, if the present state is 1, then it has to go to 0 in the next state. That is the idea. Sorry, it has to retain in the 1. Right? So if present state is 0, next state should be 1. S can be any value, but R should be 0. So this is the excitation table of a SR flip-flop. Can you understand? It is very simple to understand it. Just a pictorial representation. From the pictorial representation, we have just made a tabular column. If the present state is 0, the next state should be 0. Then what should be the value of SR? S should be 0, R can be anything, 0 or 1. If present state is 0, next state should goes to 1. Then the value of S should be 1 and R should be 0. And if present state is 1, the next state should goes to 0. The value of S should be 0 and R should be 1. And if the present state is 1, the next state should retain in 1. Then the value of S can be anything. It may be 0 or 1, but R should be 0. So this is the excitation table of a SR flip-flop. We will move on to the next one now. So you will see here we have came to D flip flop now, and we know this is the truth table. We know this one, right? So if present state is 0, and we know this one, maybe I will just write it down. This is this is a reset condition, and this is set condition, right? So anything it may be, if present state is 0 or 1, then if D is equal to 0, then the next state should goes to 0. Present state may be 0 or 1. If the D is equal to 1, then it goes to next state should be 1. We know that one, right? So now what is the thing here? See here, if the present state is 0, then next state should be also 0. Then what should be the value of D? It is 0. See here, if present state is 0, it has to retain in 0, then D is equal to 0. And if present state is 1, it has to go to 0 now. And what should be the value of D? It is 0. See here, if the present state is 1, the next state should be 0. Then what should be the D value? It has to 0. That is what we have written here. And if the present state is 0, it has to goes to 1 now to the next state. Then what should be the value of D? It is 1. So from 0, it has to goes to 1. So the value of D should be 1. And this is that one. And if present state is 1, the next state should be retained in 1. And what should be the value of D? It has to 1. See here, this is the value, right? So that is what we have written here. So this is the excitation table now, and this is the state diagram now, and the excitation table will be again same. If the present state is 0, the next state should be 0. If the present state is 0, the next state has to go to 0, then the value of D is 0. If the present state is 0, then the next state should be goes to 1, the value of D should be 1, right? And if the present state is 1, next state should goes to 0, present state is 1, next state should goes to 0, then the value of D will be 0. That is what we have written here. If the present state is 1, the next state should be retained in 1, the value of D should be 1. That is the excitation table. Very simple excitation table, because we have only one input, so it will be very simple, right? And we need to go to now JK flip flop, and we know this one. We have already seen many a times. No change condition, reset condition, and I will repeat it again and again so that it will be easy to understand, right? And this is a toggle condition, right? So we know this one already, right? So what we will do now, we will just look into this one. It is same as SR flip flop, but there will be certain changes. Small changes will be there, right? So if the present state is 0, next state should be retained in 0, then what should be the value of JK? 0 0. That is what we have written here. And if the present state is 1, and the next state should be retained in 1, and what should be the JK value? It should be 0 0. See here, 1 and then 1. So this is actually JK. Everything. This is JK. And here also it is JK. So JK value, it is 0 0. And if present state is 0, next state has to retain in 0 again. And what should be the value of JK? It can be 0, J can be 0, K can be 1. That is what we have written here. And if present state is 1, next state should goes to 0. Present state is 1, next state should goes to 0. And what should be the condition? What should be the condition? It is 0 1, J is equal to 0, K is equal to 1. This condition. And if present state is 0, next state should goes to 1. Present state is 0, next state should goes to 1. And what should be the condition? 1 0. See here, 1 0. And if present state is 1, next state should be 1. And what should be the condition? 1 1 0. So present state is 1, next state is also 1. So it is 1 0. And if present state is 0, next state should goes to 1. So present state is 0, next state should goes to 1. And what should be the value? J is equal to 1, K is equal to 1. J is equal to 1, K is equal to 1. And if present state is 1, next state should goes to 0. Next state should goes to 0. And what should be the value? It is 1 1. Present state is 1, next state should goes to 0. And what should be the value? J is equal to 1, K is equal to 1. Simply, right? So from here, you can write everything now. So this is now present state, next state. So if it is from 0 to 0 again, 0 to 0, it has to retain. Then what should be the value of J? It should be 0. And K can be 0 or 1. K can be 0 or 1. And if the present state is 0, next state should goes to 1 now. Then what should be the value of J? J should be 1. And K can be 0 or 1. K can be 0 or 1. And if present state is 1, next state should goes to 0, this condition. And K should be 1. K should be 1, but J can be 0 or 1. Right? And what is the next one? Present state is 1, next state should retain in 1. Then K should be 0. K should be 0. And J can be 0 or 1. That's all. Right? So this is the excitation table for JK flip flop, right? So this is excitation table, and as well as this is the state diagram. We generally call it as state diagram, and we remember this one so that it will be easy to understand in analyzing the synchronous sequential circuit, right? What is the next one now? T flip flop. It is same as D flip flop. Anyhow, it has very less things because you have only one input. So this is a truth table. We know this one. So truth table, and this is equation, right? Characteristics equation, right? Everything, everywhere I have written this one also. Anyhow, see here, only two conditions are there in T flip flop. This one, maybe see here, this is actually no change condition, right? This is 0, this is also 0 if T is 0, no change condition, both are same, 0 0 1 1, right? So this is actually no change condition, and this one is what? This one is what? If present state is 0, next state will goes to 1. If present state is 1, next state will goes to 0. What is this condition? This is actually toggle condition. Only two conditions in T flip flop. One is no change, another one is the toggle condition, right? We know this one already. Anyhow, see here, the same thing we have done here also. 0 and 1 is there. If present state is 0, next state should be 0. What should be this one? So T should be 0. That is what we have written here. Everything is T. This is T. This is also T. Right? So if the present state is 1, next state should be 1. What should be the value of T? It is 0. See here, present state is 1, next state is also 1. So it is 0. Right? So T is equal to 0. And if present state is 0, next state should be 1. Present state is 0, next state should be 1. And what should be the value? T is equal to 1. And if present state is 1, next state should goes to 0. Present state is 1, next state should goes to 0. And what should be the value of T? It should be 1. Right? So then this value is, this is present state and this is next state. So from 0, it has to retain in 0. Then what should be the value of T? It should be 0. And from 0 to 1, it has to go, right? So 0 to 1, what should be the value of T? It should be 1. And from 1, it has to go to 0. And what should be the value of T? It should be 1. And from 1, it has to retain again in 1. And what should be the value of T? It should be 0. That is what we have written here, right? So this is the excitation table, and this is the state diagram, and we will generally draw the state diagram. Try to understand, we generally draw the state diagrams in analyzing the or designing the synchronous sequential logic circuits. So the basics you have to understand here itself, right? From truth table you should know how to draw the state diagram, and from the state diagram you should know how to write the excitation table also, right? So from the truth table we are just deriving it in a different way to understand the sequential logic circuit. That is the uh, idea behind these excitation table, state diagram, whatever it may be. We are just writing the truth table in a different way to understand things. That's all, right? So we have just written for all the flip flops, right? So we have written for JK, D, and then SR flip flops, right? So now we know truth table, that is this one, and excitation table, that is this one, and we know the state diagram, and we know also the characteristics equation. So for every flip flop, we know all these kind of things. With the help of this one, we will see the designing and the analyzing procedure in our future classes. And now we will see one more topic. What is raise around condition in a JK flip flop? Now we have seen all the basics of flip flops, and slowly we will move on to the analyzing and designing procedure. Before that, there is a topic called raise around condition in a JK flip flop, and why it is happening, and how we can avoid the raise around conditions, right? That we will see now. Right. Now you see, this is raise around condition in JK flip flop, right? So one condition you should know, what is J is equal to 1 and K is equal to 1. What is this condition? It is a toggle condition, right? Toggle condition. What happens in the toggle condition? If Qn, and we will write it down, Qn plus 1. If this is 0, the output should goes to 1. If this is 1, the output should goes to 0. In this condition, if J is equal to 1 and K is equal to 1. That is the idea, right? So what we will do now, we try to draw the Qn plus 1 state now, maybe output of a flip flop, right? So what happens now, until maybe I'm just assuming that there is 0 in the flip flop, the present state is 0. So here maybe I will take this is a positive level trigger. What I'm assuming here, I am just assuming positive level triggering. So at positive level triggering means what happens? It will check for this condition. 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 And all other terms here, what is this value? It is no change condition. Since there is no clock pulses, so it is no change condition. It is no change condition. It is no change condition. Right? So here up to until this one we have seen, and you see here there is a positive level is here. So it will check for j and k value. What is j here? Here j is equal to 1 and k is equal to 0. What is this condition? It is a set condition, right? So if it is a set condition, then what is the graph we will have? The output should goes to 1. Obviously it goes to 1, right? Until this one, and until this point it also the value of j is 1, k is 0, and here it is a no change condition. There is no clock pulse is there, and it is a no change condition. It is 1 now. So until this point there will not be any change in the output. It will be retained in 1. And now at this point the level triggering is on now. So see here again at this instant until this one, because here j is equal to 1 and k is equal to 0. And what should be the value? It is a set condition again. So it will come until this point only. Why? Because here there is a change, here there is a change, right? Here there is a change, and in that change you see here what is the next value here, because here the clock pulse is high at level trigger, positive level triggering, high positive level triggering is there, and it has to check for j and k value. Here j becomes 0 and k is also 0. What is this condition? J is equal to 0, k is equal to 0. What is the condition? It is no change condition, right? So what happens here? The condition, the output equation, the output will be retained in 1 itself. Try to understand. Until this point both are 0 0, so it will retain. So here it is already no change condition, no change condition. Until this point the output will be 1. And here comes the problem, where here comes the problem. Until this point it is 1. See here at this point j, what is the j full value? It is 1. And what is the k value? It is 1 here. What is this condition? What is this condition? It is a toggle condition. So what happens here? What happens at this point? If j is 1, k is 1, the output is already 1, then what happens? It goes to 0. It goes to 0. It goes to 0. And again it will check again j is equal to 1, k is equal to 1. What happens? After a delay, because the flip flop has to process the whole thing, so it takes some delay. We know what is propagation delay, we have already seen, and it will come to 1 again. Since here again j is equal to 1, k is equal to 1, what happens? Again the output goes to 0. Again it takes some time, the flip flop will take some delay to take time to process the input again, because it has high level triggered here. So again this will goes to high, and again it is 1, so it will come to 0, and again it is 1, so it goes to 1. And here it is a no change condition because there is no clock pulse. So this will be retained now. And here we don't know what happens because it is an uncertain condition. Either it will be 1, maybe if the propagation delay is very high, then it might have been 0. It goes to 0 also. So what happens here? This period, what should be the Q? Either it is 1 or it is 0. We don't know that one. We don't know. Because that is depends on the propagation delay. Maybe if it is if it is 0 at this point, then it will be retained in 0 because there is a no change condition. If it is 1 at this point, it will be retained at 1. It is an uncertain output condition. And also here there is a toggle. This is race. This is race. What is this one? This is race condition. The output will be toggling from 0 and 1 until this clock pulse is live. And also you cannot say what is the output of the flip flop at this period. Either it can be 1 or 0, that depends on the propagation delay. So there are two problems here. One is a toggling is there, raise around condition is coming here, and we cannot determine or predict what is the output of the flip flop at this period. and see here the clock pulse has become high. So what is the value of j here? J is equal to 0 and k is equal to 0. And what is the value of the output should be retained at 1 here. At this point, the output should be 1, right? Output should be 1. But if it has become 0 at this point because of the propagation delay, and this point will come to 0, and we are expecting an output to be 1 here, we are getting 0. That is happening because of this race condition. And we need to avoid this race condition. Try to understand. We should avoid the race condition. And how we can avoid this race condition? There are three techniques can be done. What is that one? The propagation delay should be greater than the level triggering delay. Maybe I will write it as level delay. Right? If the flip flop takes more time than this period, then this will be at 0. Then I will get a proper output now. That is one point. And use edge triggering. Maybe I will write it as edge triggering. What is this one? If I am using edge triggering, then what it will happen? It will be seeing at this point only. Right? Maybe I will explain you a bit in the next class. And one is edge triggering, and what is the other one? We can use master slave JK flip flop. Master slave JK flip flop. Right? So we will see this one in the next class. Right? So what are all the topics we have seen in this class? See, we have started with the excitation table, and we have just written this excitation table using the state diagram for all the flip flops. This is for SR flip flop, and this is for D flip flop. This is for JK flip flop, and this is for T flip flop. And we have seen what is raise around condition in JK flip flop, and how we can avoid the raise around condition. We can use these three methods that we will see in the next class. Thank you.